here we are solving remove duplicates from sorted array problem. So the problem statement says that we are given an integer array which is sorted in non-decreasing order, and we have to remove the duplicates in place such that each unique element appears only once. The relative order of the element should be kept the same. So there are two things. One is we have to remove the duplicate elements in place, and the next is we have to maintain the relative order. So you can give this problem a read from here to here. It will basically explain how the judgment will be happening and will also be explaining the problem more precisely. In order to explain you, I will be taking help of these examples. Let's dive deep into the first example. Here it says we have an array with elements 1, 1, 2. So here if you see, 1 is repeated twice, 2 is unique. So what we have to do is we have to make changes in this nums array such that 1 which is duplicate should come only one, and we have to make that swap, that changes in this array till the point it is sorted. We have to return that length. So here if you see, the output is 2. So this is what the answer is expecting us. Let's see the next example. So here if you see, there are a lot of duplicates present in this array. So 0 is repeated twice, 1 is repeated thrice, 2 is also repeated twice, and 3 is also repeated twice. 4 is unique. What we have to do is we have to make the changes in the nums array. So the resulting nums array would be 0, 1, 2, 3, 4. So we are not concerned about what will be coming here, but the only thing that we have to maintain is the relative order of the elements. Got it? Here we have to return the length. Also have a look over the constraint. So the constraint says that there will always be at least one value present in the array, and the array elements would be ranging from -100 to 100. So got it right? The most straightforward approach that I can think of is we can create a set, and then from that set we can push elements into the main array and we can return the set length. So this will solve this problem. So if you would be presenting this solution to your interviewer, so the interviewer would be expecting you to optimize it further. For obvious reason, you are using extra space, so the interviewer would be expecting you to do in order of 1 space. Okay, so here comes our next solution. We can use a 2-pointer approach where we can maintain 1 pointer at the starting of the array. So let's consider the second example. Assume my first pointer is standing at this position, 0 position, and this is my first element. So now I will be looping from the first index, which is the second array value, towards the end, and I will be checking. So if this current traversal item, if it is equals to the initial element, if it is, we'll just move on. So since this element 0 is equals to 0, so we'll not do anything because this is the point where it is already present, right? So we will be moving on. We are at this position. So as soon as we got 1 is not equals to 0. So this is the point where we will be doing this first change. It's not equal. Now what we will be doing, we will be changing the next index, swapping with the next index just after this. In this way, the order would be maintained. Got it? We will be repeating this throughout the traversal. So let's see in the code how this will be done. Stay tuned till the last of this video. As for the first approach, I'll also be covering the ES6 way of solving that problem. So let's move on to the code. Let's proceed with the approach 1. We will be creating a set, const array set equals to new set. Okay. And in the new set, we will be creating out of the nums array which is passed to us. Now, in order to loop this set, since it will be having the unique elements, we can declare a unique array which will say array dot. We have to extract an array from the set, so we'll pass this array set. Okay, now we have the unique array with us, and we can simply loop over it till the unique array length, unique array dot length. And now we can simply set and update our nums of I to unique array of I, and this will do our job. And at last we will be returning the unique array length. Got it? So let's check again the custom test cases. So the custom test cases passes, and let's submit the approach 1. Cool. So this passes. Now let's move on to the approach number 2. Let me just comment this out. Approach 2. As discussed in the approach 2, we'll be taking 2 pointers. So let me take the first pointer, which will be our element, which will be tracking the element. So my first array element, right? That will be my first pointer. And the next pointer would be tracking over the traversals, which will be pointing towards the next index, which is 1. And now we can simply loop from the second index. We can loop from second index and towards the end of the array. Here we'll do 2 operations. First is we'll check if my nums of I is equals to the element. If it is equals to the element, then we don't have to do anything. We'll just continue. Else, if it is not equal, this is where we have to do our operations. So what we have to do is we have to just put the kth pointer to the current element, right? And we also have to update our element, right? This is our first pointer to the nums of I. Okay, so both the changes done in place, and now we can simply increase our k counter value, right? And at the last, after the loop terminates, we can simply return our k pointer. So let's try with the custom input. It passes. Now let's try to submit this problem. So great. So this approach also passes. Now we can move on towards the ES6 way of solving this problem. So let me just comment the approach 2. Now moving on to the ES6 way. Okay. So ES6 way. So for ES6 way, I will be doing the same things that we did in the approach 1. What we will be doing is we'll creating a array set, and we can simply do with this way. Okay, instead of doing this array.from and all this thing, so we can just spread out and do new set as the nums, and this is where we will be having our array set. And now we can simply just loop from the very starting towards the array set dot length, and this is where we will be just updating our nums of I with the array set. Got it? Array set of I, right? Same solution, though it's just a bit shorter than the above, and we can simply return array set dot length. Let's check against the input test cases now, and let's try to submit this. Perfect. So we were able to solve this problem, and now let's move on to the analysis. And let me just shrink this down. The approach number 1, time complexity. So the time complexity for this approach, if you see, we are just looping once. So the time complexity would be order of n, right? And there would be certain time complexity in calculating this thing, in creating this new set, but it is not a nested thing. It will be order of n, and order of n, which would be resulting to again a order of n, right? And what about the space complexity? So yes, you are right. Here the space complexity would be order of n. Why? Because we are having a set, we are creating a new variable, right? So let's move on to the approach number 2. So here the time complexity. So time complexity for approach 2 would be, so here also we just have one traversal. We are traversing from the second index towards the end of the array, and we don't have any nested operations. So again the time complexity would be order of n. What about the space complexity? So the space complexity would be order of 1, right? Space complexity order of 1. Why? Because we just have these variables and nothing else, right? So ES6 way, here definitely we have an order of n operation, and then we have order of n operation. So again it will be time complexity would be order of n, right? And then what about the space complexity? Since we have a set, it will be order of n. Okay, so that's all. Thank you.